Good morning once again, everyone. Now we are discussing about circular linked list, right? Is it right? Circular linked list, right?
Yes, sir.
Yeah, we know if you understood linear single linked list data structure, circular linked list data structure is very easy. You can easily you can implement. So that is why we are already started circular linked list. So what are the operations we have discussed about circular linked list? What are the operations we discussed the circular linked list? In the last class? Anyone please respond? Insertion is done.
Yes, sir. Insertion is done. Uh,
Insertion at the beginning, insertion at end, and
and
insertion at anywhere. Middle.
yes,
Middle also done. I thought I am thinking insertion in
middle.
end and insertion is beginning. I think it is done.
No,
Insertion middle is not
middle.
done.
Yes, sir.
Yeah. So that's what I am checking your memory. I am having complete information. I am maintaining. I will remember the things. But just I am asking how you are following. Is it right? Now I think insertion in anywhere, nothing but a middle is. I think we are not discussing. Correct? Correct. Oh, today very poor
Yes,
response. Only why
yes,
guy
sir.
is responding. Yeah. Here, please respond. Already told you. Even, okay, anyway, good. Almost 42, 43 students are practice in single link list. That practice things you are shared in the group. Yeah, nice. Here, even though remaining people you try to practice, remaining 22, 25 students, please practice and post in the group today, end of the today. And all of you, today I'm going to complete this circular linked list. This circular linked list program also I'm going to share to you. Here, on our before Sunday, means we have 2 days, Saturday and Sunday. Here, end of the Sunday, you submit your practicing things in our WhatsApp group. Don't share personally. You must share in the group. So that is good to understand how many students are sharing and what are the data you are shared. Everything I am going to save. And even though I can understand your strategy, I can maintain your total data. So then it is very easy. And you can please don't copy from others. If I am telling to share in group means you don't think it is for copying purpose. Here I am asking how much you are practicing. Okay, please. Yeah, the practice is very important. Understand my intention, everyone.
Yes,
And still, any student is having any doubts in a single linked list. Still, please respond in your chat box or unmute your mic and do that. Still. Okay, even if it is no RS, you have to post it now, please. Sir, I am not wasting your time. Just I am asking, you people are really comfortable with the single linked list. That is good thing to learn the remaining data structure. That's what I am asking. Still, any clarification or any doubt or anything is there in single linked list. I am asking about single linked list. Still, if it is yes or no, you send both the messages. Yes, also not a problem. No, also not a problem. I will tell you the solution. Okay, only two responses have came. I'm expecting all. Out of 51, 51 students. No, 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 no. Yeah, no, no. Yeah, almost 8 only came. 9, 9, all 9, no. 10, no. Means 10 students said no. 11, 12, Okay, almost 12 students are, they don't have any problem. The remaining, I can start the remaining students. Maybe you people are having 13, 14. So that is what, yeah, 15. There out of 60, 15 students doesn't have any problem. 15, 16, yeah, 17. Fast, fast, do it fast. We are, uh, 1 minute, 1 second you can test that. Then automatically we will finish up. Don't waste your time. 18 out of 60. I think 61 out of 61, 18, 19 out of 61 are not having any problem. Okay, okay. Hindu, Anjali, no. Okay, everything is fine. Okay, Ashanti also. Yeah, 22, 23, Gayatri. 24, Chandana. Okay, now it is reaching 50%. Okay, still, okay, if you want to send, you send. Yeah. Here, I will give one information to you. Tomorrow is a Saturday, right? Here, tomorrow you don't have any classwork, anything in the morning. Yes or no? Is it right? Do you have anything on morning, tomorrow morning?
No, sir.
No,
Here
sir.
now, yeah. Now I'm going to conduct one session for single linked list tomorrow. For A and B, both the sections, I'm going to send the invitation today evening. Then, if really you are facing problem with the single linked list, please join the session. It is not a mandatory session. There is no attendance consideration. Just I am telling, only the people who are not understood that particular single linked list or any doubts, you are practiced almost 40 to 45 students to accept. But out of that, any student, maybe some area you are not understood, some point you are not understood, please join the class. Then I will send the invitation today. Maybe most probably I will take the class tomorrow 10 a.m. I will share to your group. Okay, the people who are interested, you can join. Is it fine, everyone? Because the single link list is very important. That is my intent. Is it fine, everyone? Yeah. Okay, right. Good. Now we'll start our today's class. Right. Is it visible now? My screen is visible?
Yes, sir.
Yes, sir.
Yeah. Right. Now we are discussing single circular linked list. You know the difference between single linked list to circular linked list. Here in a single linked list, the last node, the next pointer of last node must be points to null. In a circular linked list, the last node next pointer points to the start node. That's why it is traversing in a circular fashion. So that is why it is a circular linked list. The difference is only one thing from single linked list to circular linked list. So based on that, we have same number of operations are available for circular linked list also. Insertion, deletion, and display. Here, you know, because of easy implementation, instead of pointing the pointer to point the first node, we are considering in circular linked list, the pointer is pointing to the last node. So that is why initially the last is null. I have assigned null to the last pointer of the structure of the circular linked list. You know, everything is same like your single linked list. Yeah, now when you want to insert a node in a circular linked list, like single linked list, we can insert at the beginning of the circular linked list. Yes, we done this how to insert beginning of the list and insert at end of the list. Here both codes are saying only one difference, one extra statement is required in this else part, that is last equal to last next, except same code for inserting a node at beginning of the list, inserting at end of the list. Both codes are same. Is it right as per the last class discussion? Yes or no? Yes or no? When you
Sir.
are going to insert end, you have to move your last to one more position. That is the difference. Otherwise, everything is same. Correct? Is it right?
Yes, sir.
Yeah. Now, one more operation in the inserting at specific location in the list means middle anywhere in the circle linked list. Here you know very well. Here, when you want to insert, you have to check two conditions, right? What is that? What is the condition you have to check? What is the condition you have to check when you want to insert a new node in a circular linked list, a single linked list? What is the condition? What is the condition, yaar? You, everyone you understood, you posted, then no one is responding. Please unmute your mic and tell. Your messages are not visible. Please. What conditions? What are the cases?
If the list is empty,
Ah, circular linked list is empty or not? Good, very good. If circular linked list is empty, then we cannot ask where you want to insert because in beginning and ending we can insert your new node as a first node it is going to work or last node it will work. But this case is what? Insertion at a specific location means you have to ask end user where should I want to insert a new node? Yes or no? Yes or no?
yes, sir. Yes,
Yeah.
sir.
The circular linked list is empty. Here, how to check what is the condition? How to check that circular linked list is empty or not? How to check? In circular linked list, how to check? What is the condition? What is the condition when you want to check the circular linked list is empty or not?
From last,
Huh? Last? How to check? Tell me.
Last equal to null.
Yeah, very good. If last equal to no. Please respond immediately. Today we are going to complete the circular linked list. Don't waste your time. Here, this circular linked list actually it is not there in your theory syllabus. Please understand. You go and check your syllabus. This circular linked list is not there in your theory syllabus, but this circular linked list is there in your laboratory program. This is the second program. Even though we know single linked list, that's why I am discussing circular linked list. Understand? Understand? Sometimes they are going to ask in your external examination also. That is why I am discussing. Are you clear?
Yes, sir.
Right. Now the single linked list is empty when you can tell the last equal to null, then the single circular linked list is empty. If the circular linked list is empty, okay, when you don't need to ask end user where should I want to insert. That's why I am going to return. Then I am going to print circular linked list is empty. I am going to return. Return means is out of the function because here how can I ask? Here, what is the function I have taken? Insert at specific location I have taken. Yes, specific means I have to ask where should I insert. Here, is it not possible to ask end user? Yes or no? Yes or no?
Yes, sir. Not possible.
Not possible to ask. Otherwise, if you want to insert that new node as a first node, if you want last node, if you want to insert, then you can write here directly without asking end users. Because if you are asking me some compulsory, you have to ask after which node I want to insert. But I don't want to, I cannot ask because there is no element. Yeah, directly you can insert, then you can insert. Means use insert as a last node you can use. Yes or no, you call that function. Yeah. Are you clear? Otherwise.
Yes, sir.
Yeah. But instead of that, I am taking, I don't want to insert because circular linked list is empty. So that's why I am returning. So this is my way of thinking. You can do your way or you can do as per the requirement of the client. Are you clear?
Yes, sir.
Yeah. Now, this is the since circular linked list is empty. If circular linked list is not empty, means circular linked list contains some elements. Yes or no?
Yes.
The circular linked list is contains some elements means Circular linked list contain one element, two element, three element, n elements. Yes or no?
Yes, sir.
Here we have to check two things. Circular linked list contains one element or more than one element. So this is very important if you are going to compare with single linked list to circular linked list. Here because here circular linked list is contain only one element. How it is? For example, circular linked list is contains only one element. How it is? Here this is a last and this last is next pointer is pointing to itself. Yes or no?
Yes, sir.
Now maybe it is looking like this. Now you want to insert a new node in a circular linked list. Here when you are going to ask a user, what you are going to ask? After which node you want to insert? Here only one element is there. Yes or no?
Yes, sir.
Here this is the existing one. Now we are trying to insert a new node. This is NN. For example, this is NN. Now you want to insert this node in a circular linked list, but circular linked list is not empty. So that's why it came to not empty. Now here I am going to check two things. Circular linked list contains only one element. Here, how to check the circular linked list is contains only one element? What is the condition? What is the condition?
If last next is last.
Yeah, last next is last. Yes, exactly. Last next equal to last. Then the circular linked list contains only one element. If circular linked list contains only one element, now I want to insert this new node. Here, how can I ask a user after which node I want to insert? Is it false? Is it right? For
Yes, sir.
example, in row, one candidate is stand. Now one new other guy has came. You wanted to stand. Now he is going to ask to you, where should I stand? No, right? Directly you go and you will ask. You will join. Yes or no?
Yes.
That's why here in this case you can directly insert this particular node maybe as a beginning as a last. Are you clear?
Yes. Yes, sir.
Otherwise, here I have not taken any choice. I don't want it. Here, this is my analysis. So that's why I have taken the printf statements. Circular linked list contains only one node. So insert beginning or end of serial. Just I am giving the information to the end user. Means if you want to insert begin or end, you can do it. Go to that function. This function cannot work. Like that I mentioned in my printf statement. Are you clear now?
Yes, sir.
Otherwise, if you want to take your own way, you don't want to tell again end user, you insert maybe a beginning or end. You directly, if you want to insert, then in this printf statement, instead of this printf statement, you can write after 10 you want to insert 5, you can insert, or before 10 you want to insert, you can insert. Like you call insert big function or insert end function here, then automatically it will be inserted beginning or end, wherever you want. That is, you can take your decision as per the client requirement. Here, generalized statement I have taken. What I have taken here, because the circular linked list contains only one element. Then, if you want to insert the new node before the circular linked list or after end of the circular linked list, if you want to insert, you can call and you can insert. Like that, I have maintained. Just I am going to display the message. Are you clear now? Are you clear?
That's a clear.
Yeah, that's what already I told you. Data structure is a mechanism to arrange the memory as per our client requirements. Here that is why here only there is no one procedure we have to follow every time. Here we can follow as per the requirement. Here that is what. Please don't blindly work out the programs in industry. Here as per the requirements, you please try to practice in different ways. The different books are going to refer different ways. Don't confuse. If you are going to refer same program internet, they will take some means arranging is same, but these assumptions are maybe the different. Understand? Understand? Inserting and managing and data structure is same, but these assumptions are going to different from person to person and requirement to requirement. Understood now?
Yes, sir.
Yeah. Now my circular linked list is not empty. Sir, not contains a single element. My circular linked list is contains more than one element. If more than one element means here that last is next. Last next is not equal to last. Means if it is false. When it is false, comes to the else part. Are you clear? Are you clear?
Clear. Clear, sir.
Yeah, if it is else means I am assuming my circular linked list contains three elements. Today we are going to complete the operations of circular linked list. Please try to cooperate and respond immediately. So then I can understand you are following. If you are not responding, again I am going to ask every time. Correct? Is this correct? The circular linked list right? As per our discussion?
Yes,
Sir?
sir.
Yeah. Right. Now, one, two, three. Now, sure, we have to create a new node. Yes, here, new node is there. Yes or no? And then, yes or no?
Yes,
First
sir.
node, new node. And here, T, I am pointing the T temporary variable to the last. Here, just I am pointing temporary variable. Okay, this is T now. Okay. Now, and then here memory, dynamic memory is allotted. You know this, I don't want to discuss much. And I want to read the data for this. I want to read the data for this particular node 5. Yes or no, you know this, right? Same
Yes,
thing.
sir.
Yeah. Now I am going to ask end user now because my single linked list not contains a single element. My circular linked list contains more than one element. More than one element. So that's why here you are going to ask end user after which node you want to insert. That's why enter data after which number is to be inserted. Are you clear now? Same like a single linked list. Yes or no?
Yeah.
Same
Yes, sir.
procedure. Only the thing is last node always next pointer points to the first node. Procedures are same. Now, for example, I given after 7 initially. X value 7. Are you clear now?
Yes, sir. Clear.
Right. Now we have to traverse in a circular linked list. You must find the node data value 7 in the circular linked list. Yes or no?
Yes, sir.
Now from where you have to traverse? You have to traverse from last node. Yes or no?
Yes.
So that is why I have taken temporary variable t equal to last. Are you clear?
Yes, sir.
Now you start your traverse. Here, what is the condition? Here, t next is not equal to last. Means we have to start from here. Here, then move to here. Here again. Here means here again. If you are not provide any condition, what happened in the circular linked list? It is going to rotate. It is going to rotate continuously. Yes or no? You have to
Yes.
stop somewhere. Means how many searches are required? Number of elements are there. How many number of elements are there in this particular circular linked list? That many comparisons are required. Somewhere you have to stop. Yes or no?
Yes, sir.
You are started from last. You have to start with last. Stop with last. Are you clear? Are you clear?
Yes, sir. Clear.
Yeah, that is why I have taken t here. The condition is t next is not equal null. T next is not equal to last. T sorry, not null. It is last. T next is not equal to last. Means it will move from here. T next is last. No. Are you clear? Then move. T next is last. No. Sir, no. Then move. T next is last. No. Yes.
Yes.
T next is yes. Then you have to stop. Means one, two, three. Three comparisons are over. Understand? So that, like that. And at the same time, I'm going to take one more condition. T data is not equal to X. We have to compare, right? Here, where is the 7? Yes or
Yes.
no? So that's
Yes,
why
sir.
T data, along with this condition, I have to check T data is not equal to X. So this condition same in your single linked list also. In the single linked list, you have taken what? T next is not equal to last. Yes or no?
Yes.
Only the difference
Yes.
is T next is not equal to null. We have taken in a single linked list. Here we don't have a null, that's why we have taken T next is not equal to last. That is the difference. Code is same. Correct?
Yeah. Yes, sir.
Yeah. Now check the first one. T next is not equal to last. True or false? True or false?
Where
T next is not equal to last. This is the T. T next is not equal to last. True or false?
false there last.
T next is not equal to last. T next is not equal to last. True or
Last.
false?
It's true.
True. Yeah, true. Then next is what? T data is not equal to X. What is T data now?
Three.
What is T data?
Three.
3.
Three, sir.
Yeah, 3 is not equal to 7. True or false?
True.
True. Both are true. Then following block is going to execute. What is that? T equal to T next. T is going to move to its next. What is that? This is the T next. Correct?
Yes, sir.
Then loop is going to iterate until unless condition is going to fail. So now T next is not equal to last. True or false? T next is not equal to false. True or false?
True. True.
True. Then T data is not equal to X.
True.
Both are true. Then
Yes,
following
sir.
block is going to execute. T equal to T next. T is moved to its next. Yes or no?
Yes.
Right. Now again loop is iterated. Here
Yeah.
T next is not equal to last. True or
False.
false? If it is
False.
false, no need to check next condition. If it is false, then everything is false. You know the logical AND operator. Then it is out of loop. Are you clear?
Yes, sir. Clear, sir.
If T is not equal to last, T is not equal to last.
False.
Huh? T is not equal to last. True or false? T is not equal to last.
Yes, sir. Not is true. Not. It's true.
Sorry?
It's true, sir. True. He is at second position. Second node.
T is not equal to last. Where we are?
Second node.
Yeah, we are here. Here now it is true or false?
It's true.
Here I think the condition is wrong. What condition I have to check? Just wait a moment. If T is not equal to last, so now we have to fail, right? We are not having this 5, right? Then what should we write here? If, tell me anyone? Here we want to
X not
insert,
equal to X not equal to data.
no. Here when we are going to do this, what should we do? X, yes. Okay, please, everyone, you replace this code. X is not equal to T data.
Yes.
Correct?
Yes, sir.
Then here you have to write, what you have to write? This statement you have to write. Data does not exist. Okay? You must write this code here, please. Okay?
Okay, sir.
Now you write this code in else part. This code is in the else part. Means the data is existed, you have to write else part. Okay?
Okay, sir.
Right now, instead of 7, we go with 2. Instead of 7, you go with 2. Now, what happened when t is rotated from here to here to, yeah, t is fine. Then what happened here? While t is not equal to, t next is not equal to last, yes, true. T data is not equal to x. What happened? False, right? False, right?
Yes, sir.
Why? Because t data is 2, x is 2. Then it will out of the loop, then it is going to check first if condition. What is that? X is not equal to t data. True or false?
It's true.
X is not equal to t data. What is x? 2. What is t data? 2. True or false?
Oh, it's false.
False. False means it moves to the else part. Here else part. In this else part, then what it is going to do? Then you are identified victim node. What is that? What is the victim node? T. Yes or no?
Yes, sir.
Here, what is the new node? NN. Then you know NN, you know T. Then you have to insert after T. Yes or no?
Yes, sir.
Now tell me how to insert. NN next equal to. NN next is what? Null, right? Yes, you have to
Yes.
write the first statement. NN next equal to.
T next.
NN next equal to T next.
T next.
Understand? NN next equal to T next. Here, this is NN next and this is the T next. Are you clear?
Yes.
Here, now this NN is connected to T next. Then after T, it must move to the NN, right? Yes or no?
Yes. Yes.
Then you write T next equal to NN. Right?
Yes, sir.
Now this particular node is inserted after 2. 1, 2, 5, 3.
3.
Correct?
Correct.
Yeah. Is it clear, everyone?
Yes, sir.
Yeah. Right. Good. Okay. Now coming to the deletion operation. Here, same way you can delete, how you are deleted in a single linked list, same way you can delete in a circular linked list also. So in the same way, we have 3 ways you can delete. That is, deleting from beginning of the list, deleting from end of the list, deleting a specific node. Okay. Now the first one is deleting from beginning of the list. Here in the same way, how you are how many cases we are having in a single linked list, same number of cases we have in a circular linked list. How many cases we have in single linked list to deleting of a particular node? How many cases, tell me? How many cases we have to verify?
By inserting from the beginning.
For deletion operation, I am asking.
Okay.
Here, how many cases we verified in a single linked list? Same number of cases we can verify in a circular linked list also. Tell me how many cases we have to verify for deletion.
If if list is empty and next list.
Yeah. The first case is list is empty or not. If the list is not, if the list is empty, we cannot delete anything. Correct?
Yes, sir.
Sir, how to check the list is empty?
If the last is equal to null.
Last equal to null. If the last equal to null, the circular linked list is empty. That's why we cannot delete any element from the circular linked list because the list is already empty. You have to print the message. Are you clear?
Yes, sir.
Sir, another one is the list is not empty. Means if the list is not empty means the last never points to null. The last never points to
Null.
null. Are you clear? Then list
Yes.
is not empty. So in this list is not empty, we have again how many cases we have to check? How many cases we have to check?
Two.
Two cases. What are those two cases?
If list has only single element or null.
List contains only single elements or more than one element.
One element.
Because we know we are after deletion, the things are going to change. So that's why we have to check two things, right? The first one is list is having single element. Then how to check the circle list is having single element? What is the condition? What is the representation?
If
How
last
to check?
next is pointing to last, then we can say list has
Yeah, very good. Here list contains only one element means here already only one element means that is the last element in a circular linked list. Then that is going to points itself. So then we can understand this is a circular linked list. It contains only single element. If the single element contains circular linked list, the last next is pointing to itself. The last next equal to last. So that is the condition you have to verify. Last next equal to last. Are you clear?
clear, sir.
Yeah. Now, if we want to delete this, we want to delete right anyway because we are going to delete what? Want to delete beginning of the list. Here, when we are going to have only single element in a circular linked list or single linked list, whatever it is, if it contains only one element means we can delete beginning or last same. Yes or no? Because it contains one element. Maybe it is last, maybe it is start. Yes or no? When it contains single element. Yes or no? Yes
Yes.
or no?
Yes.
Yeah.
Yes, sir.
Then we have to delete. Here, when we have to delete, compulsory we have to take the temporary variable. Yes or no?
Yes, sir.
So that is why. So that is why we are going to assign a temporary variable to the last. That is why struct node t equal to last. Why temporary variable? You know, correct? Already we discussed it. What is the need of temporary variable? Because after last is assigned to the null, because when you want to delete, what should we do? Last we are going to assign with what?
Null.
Null. Here that is what? Here this is the statement. Last equal to null. When after assigning null, the memory already created. If you are not assigning any temporary variable to this particular memory, your memory is allotted. We cannot access, we cannot delete unnecessarily. We are going to waste the memory every time. So that's why you have to assign this particular last to temporary variable before assigning null to last. Are you clear?
Clear.
Yeah, next the task is what? We have to delete the tree. But before deleting the tree, you have to make it, we have to break the link. Always I told you, when you are going to delete any element, you must be break the links before that. That is a good programmer style. Okay, without breaking also you can do it, but some of the things are available after deleting directly in the memory. That is why you have to break the link. What is the link here? T next equal to T, right? You have to do the T next equal to null. Understand?
Hmm.
You are breaking the link.
Yes,
Sir, no. Link
Yes.
breaking is nothing but you have to assign the null. Null means not defined. We are not maintaining the any memory block address here. That is what null. Already I told you very clearly with some examples dealing of the single link list. Clear?
Yes, sir.
So then we can delete the T. How to delete? Free of T as per dynamic structure. Is it clear?
Yes, sir.
Yeah. Now, once the circular linked list contains only one element, yes, you can delete that particular element at the beginning. No, my circular linked list contains more than one element. More than one element means it's never true. The condition is last next is not equal to, sorry, last next equal to last must be a false. Yes or no? Yes or no?
Yes, sir.
Yeah. Now, when circular linked list contains more than one element, then you want to delete first node. Then I am just assuming three elements. Please respond immediately. We have 20 minutes only. We have to complete all the operations of circular linked list. Because you will get 2 days, Saturday and Sunday, to practice circular linked list. Then on Monday or next class, or whenever it is there, then you can discuss more things, any doubts or any clarifications. And even though you have to practice these 2 days for circular linked list, the people who are not practicing single linked list, along with circular linked list, you practice. Okay, please. Right. Now, that is my intention. Please understand, cooperate, support. Okay. Time is running, already the timetable, already the academic calendar is there, already released. That's why please have to follow. So now I am assuming my circle list contains three elements. Are you clear? One, two, three.
Yes.
Now when my circle linked list contains three elements, then what should we do? We have to delete first node. Yes or no?
Yes.
We have to delete first node. So if you want to delete first node, then you have to identify the first node maybe this. After deleting what happened, this last point to this node. Yes or no? Instead of first node, this last is pointing to this node. So this is the idea. Are you clear?
Yes, sir.
Yes or no?
Yes, sir. Clear.
If you wanted to delete this, you must find the first node. Here, how to find the first node? Last next is the first always in circular linked list. Yes or no? Last next
Yes.
is the first node. Correct? That's why I declared one temporary variable t. It is going to point to the t equal to last next. Now this is a first node. Now you want to delete this node because whenever you want to delete any node, you are going to identify that node. Yes or no? Yes or no? If you want to delete any node, you are going to identify that node. Then only it is possible to delete. Yes or no?
Yes. Yes. Yes.
Now that's why I identified. Very simple. There is no such thing. That's what I told you. When you are going to delete or insertion in a circular linked list, if you are having last pointer, it is very easy to find the first element, last element. Otherwise, if you take start, the confusions are more. Okay? Now understand my intention. Why I have taken last pointer. Understand everyone?
Yes, sir.
Even you can try, if you are having tried, you can take first node as a first node as a start pointer. You can do it. It is going to work 100%. But some confusion, number of lines of code you have tried for. That is the difference. Otherwise, everything is same. Right. Now you know the last node. Now you know the first node. You want to delete this first node. Then the logic is very simple. Tell me anyone. Tell me anyone. You know last. You know first. Then tell me anyone how to delete this T. So when you want to delete this T, what should we do? You have to break the link, right? Tell me how to break.
Assign T next as null.
Assign T next as a null. Directly, if you are going to assign, the problem will come. First of all, what should we do? You have to make it circular linked list. Then you have to do. Last next is what now? T. But after deletion of this T, what is the last next?
Second.
Means T next.
Two.
Here, understand the logical way. Okay. Sir, what is the after deleting of this T? What is the last next? The last next is T next. And simple. The code is came now. Last next equal to
T next.
last next equal to T next. Means here instead of this link, here this is going to point to T next. Are you clear?
Yes.
Now last next is what T next. Here what happened after last? It is moving to T next only, but it never goes to T. Then you have to delete T. Sir, this is our agenda. Now, before deleting this T, you have to break the links. Even any link is there. Yes, it is there. One link is where breaked. Okay. Here one more link is there. This T is pointing to again this another node. Yes or no? Then what should
Yes,
we
sir.
write? T next equal to null.
Null.
Means you are making T next equal to null. Are you clear? Now this is free from this circular linked list. Yes or no? This node is free from the circular linked list or not? There is no connection. Yes or no?
Yes, sir.
Here, after understanding this, after verification of all links are closed, then you have to delete this dynamic memory. That's what free of T. Is it clear?
Yes, sir.
Yeah. Now next is deleting from end of the list. Here also you have to verify two same conditions. Here three. First is what? The list is empty or not? Yes or no?
Yeah.
The list is empty. We cannot delete any element. Yes or no?
Yes, sir.
So if the list is not empty, you move to the else part. Correct?
Yes.
In this else part, again, how many conditions are there?
2.
What are those?
If the list has only single element or more than.
If the list contains only one element, then you know same code you will work. Means just you have to remove the last next equal to last. Instead of that, you have to write last next equal to null. Before that, you have to define t equal to last. Yes or no? Then you have to assign last equal to null. Then you have to write free of t. Are you clear?
Clear.
Same code. Here nothing is there. Here, no, my list is having more than one element. Means when this condition is going to skip. Yes or no? It moves to the else part. Yes or no?
Yes, sir.
Yes or no?
Yes.
Now just I am assuming list contains more than one element. The list contains three elements. Or four elements. I am taking now four elements. You can draw n number of elements. What is your convenient? Then in that way you have to take elements. Don't blindly follow my examples. Even though you can change, modify your examples and check accordingly as per your requirements. 1, 2. Even you can use character data also. Okay. In data structure, you define char. Then you can take A, B, C, D. Okay, don't follow always integer or my things. Are you clear? You have to check everything. Clear? For single linked list also. Are you clear? Instead of writing into data in data structure, you write char data. Then you can use ABCD characters. Right. Here I am assuming four elements are there in my circular linked list. Now I want to delete which element? Which element I want to delete? Last element. Correct?
Yes, sir.
Yeah. Now I am means which element I want to delete? Last, right? This element, right?
Yes.
Now if I want to delete this element, you have to identify, right?
Yes, sir.
What element you want to delete, you have to identify. That's why I have taken T1 node T1 as a struct node and T last equal to next. First of all, what I have taken here, what is T now? Where is T? T equal to last next. What is last next?
Last next is first.
Last next is the first node. Why I have taken T1, I will tell you first. Now I want to delete which node?
Last.
I want to delete which node? Last node, right? Right. Now if I want to delete this node, here this previous last node must be connected to the first node. Yes or no?
Yes, sir.
But how to find this previous last node? How to find the previous last node? How to find this node? You have to find. Then only we can connect to this node. Yes or no?
Yes.
Then how to find this? Because in a circle linked list and in a single linked list, we have only forward direction, right?
Yes.
Like that we have to move. There is
More
no
than
backward direction. So that's why we need one temporary variable to traverse in a circular linked list from last. Are you clear? To
Yes.
find the last but one node in a circular linked list. Are you clear? That's why I have taken T1 temporary variable to traverse in a circular linked list. Understand now?
Yes.
Sorry, this is T, right? Understand now?
Yes, sir.
Now T equal to last next. Now T equal to last next. This is the T. This is the T. Are you clear?
Yes, sir.
Yeah. Now, just I have to traverse unless I have to find the last. Sir, when you have to stop? Before the last, I have to stop. Sir, how to find that before the last? T next
T.
is not equal to null. T next is not equal to null. Yes or no?
Yes, sir.
Then, if it is true, then T equal to T next. Now tell me, T is next is not equal to last. Yes or no? True or
Yes.
false?
True.
True. Then the following block is going to execute. What is that? T moves to its next. Now T moves to its next. Now T next is not equal to last. True or false?
True.
True. Then T moves to its next. Now T next is not equal to last. True or false?
False.
False. Then out of the loop. Correct. This is the victim node. Yes or no?
Yes, sir.
Now we have to delete which node? Last node. Then you know T, you know last next. Yes or no?
Yes, sir.
Yes or no?
Yes, sir. Yes, sir.
Then how to write?
T next equals to last next.
T next equal to last next. Here, T next. T next is what? It is pointing to last. T next equal to
Last.
last next. Very good. Here, two links are there again. Here, 3 is moved, T next is moved to the first node, and last next also moved to the first node. Yes or no?
Yes.
Right. Now, tell me, now, what is the last now? T is the last.
Yes.
Yes or no? Yes,
Yes,
but here T is the last. But when you are moving this last equality, then you cannot delete that. Here, before that, we have to take one more temporary variable before deleting this. Yes or no?
Yep.
That's why I have taken T1 equal to last. Are you clear?
Yes, sir.
Now T1 equal last. Now what is the last now?
Last T1.
Hey, what is okay? This is okay. After connection of this, what is the last one in circular linked list?
Third node. T.
T1 or T? T, right? That's why you have to assign last equal to T. Now T is pointing to sorry, last is pointing to here. Are you clear?
Yes, sir.
If you are not doing this directly, if you are not assigning T1 to last, directly if you are going to assign last equal to T, here we never find this address. Are you clear?
Clear, sir.
Yeah. Last equal to T. Now this is a T1, not a last. Last is now T. So this is a T1 only. Now we have to delete this T1, right?
Yes.
Before deleting T1, we are going to verify any links are available, any connections are there. Yes, it is there. T1 is pointing to T. T1 next is pointing to T, right?
Yep.
So that's why you have to make it T1 next is null before deletion. Yes or no?
Yes, sir.
So this is the code. T1 next equal to null. Clear?
Clear.
Now this T1 is free from the circular linked list. There is no any link connection. Yes or no?
Yes, sir.
Then you can apply free of T. Done?
Done.
Yeah, in this way we can delete the element in a last node in a circular linked list. Is it clear now?
Clear. Clear.
Yeah. deleting a specific node from the list. Shall I continue? Shall I complete?
Yes, sir. Completed.
Yeah, thank you. Because tomorrow, day after tomorrow, you don't have, that's why you have to work it. Please, maybe it will take 10 minutes more, maybe please support. Now delete it anywhere. Now same logic. When I want to delete, you have to check what? List is empty or not. Yes or no? If the list is empty, we cannot delete any element. Yes or no?
Yes.
Here, if the list is not empty, then we have to check how many conditions again.
2.
Here, one is list contains single element. We have to do this task. List contains single element. What should we do? We have to assign t equal to last. Yes or no? Then,
Yes.
then last equal to null. Then t next equal to null. Then free of t. Yes or no?
Yes. Yes.
Same conditions. Nothing is there. Copy paste. You can do it. If you are understood, you can copy and paste it. Not a problem. Everything is same. Are you clear?
Clear.
If the list contains more than one element, then we have to ask end user which element I want to delete. Yes or no?
Yes, sir.
Yeah, just I am considering 4 nodes in my circular linked list. Means 4 elements. 4 nodes means 4 elements. Simple. One, 2, 3, and 4. Right. Now this is a last. Are you clear now?
Clear.
Now, sir, which element you have to delete? We have to ask end user which element I want to delete. Yes or no?
Yes, sir.
Yeah. Now, sure, now we are going to ask end user which element I want to delete. Clear?
Yes.
Now I want to delete 5. He entered 5. Now we have to search 5. The 5 is existed or not. If the 5 is existed, we have to identify that location, address,
Yeah.
using one temporary variable. If the 5 is not existed, we have to print that element is not existed. These are the two things, yes or no?
Yes, sir.
Yeah. Now we have to assign here, while right, here.
Yep.
Where is if? Now you know, here this is a last node. Here T1 equal to T next. Here what is T? What is T? T is a, here we have declared else part.
Last.
This is a global declaration for this else part. Please remember. Now T is this. Okay.
Yes.
Now we have to traverse from first to last, because to identify this 5 node is available in this circular linked list or not. Yes or no? That's why I declared T1 equal to T next. So this is a T1. Correct?
Correct.
T1 equal to T next. T next we are assigning to T1. That's why T1 equal to T next. So this is a first, this is a last. We have to traverse from T1 to T and find the 5 is available or not. If the 5 is there, then you can delete. So this is the logic. Understand?
Yeah. Yes.
Yeah, that is why this while loop also, you know how to write while loop. Simple. T1 is not equal to last. So T1 is moving from first to last. Then when you are going to move this T, then we can stop the traversing, because all the elements are verified. That element is not existed in the list. Yes or no?
Yes, sir.
And in the same time, if T1 is not T, then you have to check the data. So the data is equal to the given data or not, means 5 or not. Yes or no? So these are the two conditions. Now already we know, instead of this last we have taken null in a single linked list. So this is the difference. The remaining things is same. Correct?
Correct, sir.
Yeah. Now tell me, T1 is last now?
No.
No, true. Then T1 data. What is T1 data?
1.
1. Now we have to compare with 5. True. Both are true. The following code must be executed. What is the following code? T moves to T next. T1 moves to T1 next. Understand?
Yes.
T moves to T next. T1 moves to
T1.
Understood this?
Yes, sir.
Right. Now loop will be iterating.
Again,
Now tell me.
T1 data is not equals to X. True. And T1 is not equals to last.
Now again it will be moved. T will come here.
T1 will move to next. So now,
Understand?
yes.
Now
T1 is
again iteration. Again iteration. Then T1 data. What is T1 data? 3.
3.
Not equal to true.
True.
Then
But
T1 is not equal to last. True. Both are true. Again T1 moves to its next, and T moves to its next. Please don't confuse. Very simple. Same thing I have used in single linked list also. Instead of last, I have taken null there. Right. Now in this again iteration. Now T1 T1 data is not equal to S. True. Now T1 is not equal to last. False. Yes or no? Now T is pointing to last. If it is false, out of the loop. Are you clear?
yes, sir.
Means T next is equal to last now.
Yes.
T next equal to last now. False.
Yes.
Yes or no?
Yes, sir.
Yes. If it is true, then what happened? Data
Does not exist.
does not exist. We have to print. Clear?
Clear.
Here, if I given 3 as an input, understand?
Yeah. Yes, sir.
Then just I am undoing all these things. Yeah. Now I have given 3 as a data I want to delete. I taken from the end user. Then tell me, here what happened? T data, T1 data. T1 data is what? 1.
1.
Sir, no.
Yes.
It is not equal to 3. Then
3.
true.
True.
Here T1 is not equal to last. Yes, true. Both are true. Then T1 moves to T1 next. T moves to
T next.
T next. Right, very good. Now again iteration. Now same. Here T1 data is not equal to 2 and T1 is not equal to last. Again what happened? T moves to T next. T1 moves to T1 next. Now next iteration. T1 data is not equal to X. What is T1 data?
3.
Now X is 3. Now what happened? Condition is false. No
Yeah.
need to check next condition. Then
If
out of the
more of 2y.
now tell me, T next is equal to last? False.
False. That's false.
Now what is T? Here T next is T1 only. Here T next is not a last, correct?
Yes, sir.
Then again it moves to the else part. Are you clear?
Clear.
Now means you are identified a victim node. What node you want to delete? T1 you are going to delete. You must delete T, right? T1, right?
Yes, sir.
Now you know T and you know T1. Yes or no? You know T and you know T1.
T1.
Just you have to delete this. How to delete? Simple logic. T next is T1. Instead of that, you have to write T next equal to
T1.
T1 next. Very good. Then this link will be gone. Okay, T next equal to T1 next. Are you clear?
Yes, sir.
Now we are deleted means we are unlinked this, but still we are not deleting because T1 is having some link to our circular linked list. What is that? T1 next equal to some node
Null.
is there. Then you
Yes.
have to make it null. Then what should we write? T1 next equal to
Null.
null. Now it is not linked
Fine.
to our circular linked list. It is a free. Then you can apply free of T1.
Yes.
Sir, we can delete any node in a circular linked list in this way. Are you clear now?
Clear, sir.
Yeah. Only the last operation, that's a display operation, very easy. Okay, how many ways you can display, how many cases you have to check display operation as per the single linked list? How many ways? How many cases you have to check? Please respond fast. How many ways? Oh, no one is responding. Are you there?
Yes, sir. Yes, yes.
How many ways?
Only
How many? Two cases are there. One is
yeah, two cases.
circular linked
Only
list is empty. Another one is circular linked list is not empty. If circular linked list is empty, we cannot display any element, right? CLL is empty. Yes or no?
Yes.
Same. How to check that circular linked list is empty? What is the condition? If
Last is null,
last equal
then
to null. Very good. Same in like your single linked list. Now, if circular linked list is having some elements, then it moves to the else part. For example, I will consider my circular linked list contains. Please give me a 2 minutes of time. We will finish up. 3 elements. Now this is a last 1, 2, 3. Now maybe it is not a null. The circular linked list contains some elements. Maybe it is 1 element, 2 element, 3 element, immaterial. You have to print it, right? Understand?
yes, sir.
Yeah. Now we need 2 variables. Already I told you, one variable is pointing to the last, another variable is pointing to the first. We have to traverse from first to last. Even it is a circular linked list also, we have to identify first and last. That is very important. Always our linear data structures traversing from start to last. Are you clear? That's why I need 2 temporary variables, T and T1. Are you clear?
Yes.
So T equal to last next. T equal to last next. What is the last next? First. Last next is first, right?
Yes.
Yeah, T. I assigned T as a last next. Now T1 equal to T. Okay, now T1 equal to
T.
T. What is the meaning? Sure. Now means I have to traverse with one variable, okay, that is T, and I am sticking with T1 in the first node. That is the meaning. Are you clear?
Yes, sir. Clear.
Yeah. Now I am going to print the variables one by one. Okay. T next is not equal to T. T next is not equal to T. T next is T.
No.
No. If it is no, then print T data. What is T data?
1.
1. So after printing T data, T is moved to T next.
next.
Are you clear?
Clear.
Now, next iteration. Again, T next is not equal to T1. What is T next? It is not a T1. True, right? If it is true, following block has to execute. What is T data? We have to print. What is that? True. Then T moves to its next. Are you clear?
Yes, sir.
Now T. So now T next is not equal to T1.
Here T next is equal to T1.
T next is not equal to T1. T next is not equal to, but T next is T1, right?
Yes.
Now condition is fail. Yes or no?
Yes, sir.
Out of the loop.
Last.
out of the loop, right? Here I have written one more statement. What is that? Printf T data. What is the T data now?
3.
Clear?
Clear, sir.
Now all the elements are going to print in a circular linked list. Yes or no?
Yes, sir.
Yes, this is the way. Is there any alternate for this? You can do that. If there is no alternate, I think I have already all verified. If it is there anything, you can do that. Clear now?
Clear, sir.
Yeah, please practice. Just I am going to close. Please practice. People who are not practiced circular linked list, sorry,